The topic we are going to explore direct method of converting a regular expression to DFA using syntax trees. We'll discuss rules for converting the function. This method involves computing three key functions for each node in the syntax tree: null level of n, first pass of n, and last pass of n. Null level of n, the sub-expression generate epsilon, that is empty string. First pass of n, set of position that can appear first in the string generated by the sub-expression. And last pass of n, set of position that can appear last in the string generated by the sub-expression. These are used to build the DFA directly from the regular expressions without constructing a NFA first. A leaf labeled by epsilon, this node represents the empty string epsilon, which does not consume any input symbol since it represents the empty string. It is clear that this expression can be null. So null level of n is true. So it does not generate any actual position or symbol. Both first pass of n and last pass of n are empty set. Next, a leaf with the position I. This node represents a symbol in the regular expression such as A or B and is assigned a unique position I in the syntax tree. Since it is an actual input symbol and not epsilon, it cannot be nullable. So nullable of n is false. This first pass of n and last pass of n both contains the position I, because the symbol is both the first and the last symbols in its expression. An OR node C1 or C2, this node represents a choice between two expressions, either C1 or C2. In terms of nullability, this node is nullable if either one of the sub-expression is nullable. That's why nullable of n equal to nullable of C1 or nullable of C2. As for positions, position of n includes all positions that could appear first from either C1 or C2. That is union of their first positions. And last pass of n includes all positions that could appear last. That is union of last position of C1 and C2. Next, a concatenation node C1.C2. This node represents the concatenation of two sub-expressions. It is nullable only if both C1 and C2 are nullable. Because to get an empty string from their concatenation, both must generate epsilon. So nullable of n equal to nullable of C1 and nullable of C2. Now for positions, for first pass of n, if C1 is nullable, then string may begin with position from either C1 or C2. So first pass of n equal to first pass of C1 union first pass of C2. Otherwise, it's just first pass of C1. Similarly, for last pass of n, if C2 is nullable, then string may end with position from either C2 or C1. So last pass of n equal to last pass of C1 union last pass of C2. Otherwise, it's just last pass of C2. Finally, a star node C1. This node represents the clean star operation, 0 or more repetitions of a sub-expression. Since the star operation always includes the empty string, you can choose to repeat 0 times. Nullable of n is always true. The position where string can start and end are always from the same sub-expression. So first of n equal to first of C1 and last pass of n equal to last pass of C1. I hope you all have understood the rules for computing the function. If you have any doubts, feel free to leave a comment in the comment section. Thank you.